Culturing healthy test organisms is an essential step in conducting toxicity tests. This training video illustrates methods used for culturing the Mysids Americamysis bahia for use in the 7-day survival, growth, and fecundity toxicity test. The methods demonstrated are used by the U.S. EPA's Office of Research and Development's National Health and Environmental Effects Research Laboratory, or NHEERL, Atlantic Ecology Division in Narragansett, Rhode Island. Mysids are epibenthic invertebrates ranging in length from 4.4 millimeters to 9.4 millimeters. They are normally found in the Gulf of Mexico and along the Atlantic coast and are used in test procedures as an indicator species for aquatic toxicity. Topics that will be covered include selecting and preparing culture water, choosing a water delivery system, starting and maintaining cultures, feeding the mysids, and culturing juvenile mysids for test use. The methods presented here are examples of EPA recommended procedures used by NHEERL experts. However, modifications may be necessary to meet state water quality standards and National Pollutant Discharge Elimination System, or NPDES, permit requirements. Culture water. The source for the culture water is one of the most important considerations in culturing test organisms. In all cases, culture water should come from an uncontaminated, consistent, and reliable source. Natural seawater is the recommended culture water, but hypersaline brine may be used to make up the culture water if natural seawater is not available. Natural seawater should always be collected from a contaminant-free environment and should be filtered before use. The salinity of the water should be at least 20 parts per thousand, but no higher than 30 parts per thousand. EPA recommends conducting reference toxicant tests at least once each month to analyze the culture water being used and to check the species sensitivity of the mass culture. The recommended reference toxicants are copper sulfate, cadmium chloride, or sodium dodecyl sulfate. Water conditions should be maintained at optimum levels for proper growth and reproduction of the mysids. Generally found in waters with salinities of 20 to 25 parts per thousand, Americamysis bahia can survive and reproduce well at salinities near 30 parts per thousand. Whatever salinity is chosen, the culture water should be maintained within plus or minus 2 parts per thousand. The receiving water's salinity at EPA's Narragansett laboratory is approximately 30 parts per thousand. Good quality salt water will usually have a dissolved oxygen level of approximately 7 milligrams per liter and should not fall below 5 milligrams per liter at 30 parts per thousand salinity. If the culture water and required salinity are not 30 parts per thousand, the optimum dissolved oxygen should be adjusted. The pH should be maintained at 8 plus or minus 0.3. The water temperature should be maintained at 26 plus or minus 1 degree Celsius, and the photo period should be regulated at 16 light hours and 8 dark hours, with a gradual on-off period. It is important that accurate and clear records be kept during all the culturing procedures. Water delivery systems. A flow-through water delivery system is the most desirable arrangement for mysid cultures. Water flow into the culture tanks should be 4 to 5 liters per hour at a minimum and should be conducive to feeding while not disturbing the mysids. The delivery system should be constructed of polyvinyl chloride or PVC pipe. Glued PVC should be well cured and rinsed before using the pipes to carry culture water. Do not use materials made of rubber, copper, or brass because these materials are toxic to mysids. Glass, fiberglass, Teflon, and PVC are the recommended construction materials. Alternately, you can use a recirculating system to culture mysids. However, a biofiltering system must be added. This can be constructed with any non-toxic high surface area material, such as crushed coral or dolomite. The flow rates through the tanks of either the flow-through or recirculating systems should result in a minimum of 2 complete turnovers per day. In a static system, each tank is independent of the others and must be supplied with an undergravel filter. This method can help prevent complete culture crashes because occurrence of disease is restricted to one tank. However, evaporation in static tanks results in an increased salinity, and therefore static systems often require more maintenance than flow-through or recirculating systems. Several tank sizes are used to culture mysids. The most common are 20 or 29-gallon tanks. Wider tanks are preferable to taller tanks because mysids require a large surface area. If the flow to a culture tank is not continuous, even if intermittent, an undergravel filter should be installed. Starting cultures. Once your culturing system is designed, built, and seasoned, you can purchase mysids from many different commercial suppliers. Be sure to select a supplier carefully to avoid culturing problems or crashes. Starter cultures can be composed of adults or newly released juveniles, and suppliers should certify that the correct species is sent. Purchasing juveniles provides additional time to learn the biology of the mysid, but of course will delay the startup time of a mature culture. Once mysids are received, it's important to acclimate them to your specific culture water and conditions. Increases or decreases in salinity and temperature should not be more than 2 parts per thousand or 2 degrees Celsius per day. When receiving new shipments of mysids, try to match the culture water to the water that the mysids were shipped in. Then slowly adjust the water conditions to optimum culturing conditions. The stocking density for proper growth and fecundity is approximately 500 adult mysids per 20-gallon tank. Juveniles can be stocked in larger numbers. Mysids produce live young called early juveniles. These juveniles grow and mature to the young adult stage in about 12 to 16 days. At about 20 days old, females produce their first brood and continue to release broods for a few months. The female carries embryos in a brood pouch on the ventral side of the thorax. A gravid female can be identified by the dark color of the developing embryos in the brood pouch. Males are more difficult to identify, but can be distinguished by the presence of large swimmerets or pleopods on the ventral side of the abdomen. Maintaining cultures. Several methods are used to maintain cultures and to collect test organisms. 24-hour-old juveniles should be collected by removing gravid females from a minimum of 3 different tanks. Gravid females are ready to release their young when dark eye spots can be seen in the brood pouch. While selecting gravid females, also check the sex ratio and density of the culture tanks and adjust the tanks to a ratio of 2 females to 1 male. Once the females are selected, they are placed into brood chambers. The brood chambers are large separatory funnels with 4-liter beakers placed inside them to serve as a containment vessel for the females. The solid plastic bottom of the beaker is replaced with a 1 mm mesh screen. The screen size should be small enough to prevent the adults from passing through, yet large enough to allow the passage of newly released young. Carefully place the females into the beaker inside the brood chamber. Feed them Artemia nauplii and provide gentle aeration and/or water flow for overnight release of young. An overflow outlet must be available if water flow is used. The next morning, slowly drain the funnel into a 300-micron mesh screen cup to capture the juveniles. To prevent injury to the young mysids, partially submerge the cup in seawater. Rinse the sides of the funnel 2 to 3 times to gently wash the juveniles out of the funnel as it drains. The adult females can be placed back into the culture tanks. Use the juveniles for immediate testing or hold them in separate tanks for future testing. At least once each month, lightly clean the culture tanks. Gently scrape the sides of the tanks to remove the algae growth. And gently stir the gravel to dislodge accumulated debris, which will clear the dolomite filter. Approximately twice a year, the tank should be completely emptied, scrubbed, and the gravel replaced. With the exception of daily feeding, monthly cleaning, and the culling of males, the animals should remain undisturbed. If these guidelines are followed consistently, the population in the tank should be maintained. Feeding. Mysids, both the juveniles and the adults, should be fed proven quality Artemia nauplii twice daily. Artemia are a saltwater invertebrate commonly referred to as brine shrimp, and nauplii are the newly hatched Artemia. To ensure a high percentage hatch, use approximately 10 milliliters of contaminant-free dry Artemia cysts to 1 liter of seawater. Aerate the mixture vigorously with filtered air to prevent the cysts from sinking. Record the date and time that the culture was started. To harvest the nauplii the next day, remove the airline, allowing the nauplii and cysts to separate for about 5 minutes. The empty cysts will float and the nauplii will descend to the neck of the chamber. To speed the separation, a black hood can be put over the top of the chamber and a light source directed at the bottom of the chamber because the Artemia nauplii are attracted to light. Drain or siphon out the nauplii. It is important to remember to provide aeration to the nauplii if they remain in the collection container for more than a few minutes before being used. Periodically check the density of the Artemia culture by counting an aliquot under a microscope. This will be used to determine the concentration for feeding and serve as a check for consistency of feeding rates. The concentration for feeding should be adjusted to approximately 150 Artemia per mysid per day, or 75 Artemia per mysid per feeding. Before using the nauplii to feed mysids, rinse the harvested nauplii with clean seawater to remove chemicals released during hatching. The nauplii should be about 36 to 48 hours old from the time of initial hydration. Resuspend the nauplii in seawater to the correct volume depending on the Artemia culture density. Feed the mysids a predetermined amount of Artemia nauplii twice each day, in the morning and afternoon, so that there is always a supply of live nauplii on which to feed. The methods presented in this video should help you develop successful mysid cultures. As with many laboratory methods, slight adjustments may be necessary to accommodate different testing needs, water types, laboratory space, or equipment. More information on culturing Americamycis bahia can be found in EPA's 2002 document, Short-Term Methods for Estimating the Chronic Toxicity of Effluents and Receiving Waters to Marine and Estuarine Organisms, 3rd edition, and in the supplemental guide provided with this video.